All right, so I found my mistake here. When I distributed this term here, I excluded this j times 3 times 0.1. I excluded the I1 from this term. So let me just erase everything below that, shift everything over, and throw an I1 in there. And I think everything should be good because I checked everything else and I didn't see any other issues. All right, so here we get 12 minus ji1 plus j.3 minus j.6. So I think this is going to be negative j times 1.6 plus 0.3 gives me a minus j 1.3. So this should be j times 1.3 times I1. I just did a lot of mental math, so I wouldn't be surprised if I screwed something up. But let's give it a shot. 12 divided by 1.3 times I. Something's not right here either. What did I screw up now? Oh, one of these terms doesn't have a j in it. Yeah, the two j's go away here, so I guess I made two mistakes. So this should also be fixed. Okay, so I'm just a mess right now. It's late. It's late at night. I've been doing this for a while. All right, so let's fix that. Now we're good. Now I'm convinced that we're good. Okay, so 12 minus j plus j 0.3. I should just stop skipping steps. That's what I should do. And that's going to give me a minus j I1 times 0.7. And then I get a minus 0.6 I1 equals 0. I can add those terms to the other side. I get I1 times 0.6 plus j 0.7. And now I1 should be 12 divided by 0.6 plus j 0.7. And let's see what I get here. If this is wrong, then I'm definitely calling it a night. 0.6 plus 0.7i. That looks reasonable. I convert this to a phasor, 13.01. Angle, negative 49.4 degrees. Let's check if that is correct according to the book. That is correct. Awesome. Okay, so now we're in the green here. Okay, and of course I could also write the rectangular version of this. That's what I've got in my calculator as well, but usually the phasor is more interesting to us. So let's just box that for I1. And then I want to find I2. I gave myself another slide for this problem, but again, I'm probably not going to need it. Let's just find I2 real quick. I2 is just I1 multiplied by j 0.2 plus 0.1. So let me multiply this in my calculator. 0.1 plus 0.2i. And then let me convert that to a phasor as well. And I get that I2 is 2.91 angle 14.04 degrees amps. And that is correct according to the textbook. Okay, awesome. So these are both good. And that is how you solve this problem. Okay, again, I think that the most challenging part is converting the circuit, determining the polarities of these voltage sources, these induced voltage sources. You'll notice that in the loop with I1, the induced voltage source is dependent upon the value of I2 because this coil here is inducing a current and thereby a voltage in this other coil, in this other circuit, and vice versa over here on the side with I2. This dependent voltage source is dependent on I1 because this current I1 is what's inducing that voltage in the other loop. Okay, so if you have questions about this is basically just plain old mesh analysis from Module 1. Obviously, if you have questions, let me know, but hopefully this is not too challenging for you at this point. This is where the challenge is converting the circuit and getting it ready to solve. So if you have questions, obviously let me know. I know it's confusing. but we're going to get through it. All right, so we're going to end this video, and in the next video, I'm going to, skip this slide because I didn't need all this space that I thought I was going to need, and we're going to solve another practice problem, but from the ULB textbook this time, okay? So I'll end this video right here.